Assalamualaikum and good evening. My name is Luqman Hakim and I want to present to you about my project development of sandwich sugarcane fiber and epoxy with aluminium honeycomb panel. These days, construction of a building use concrete to create a sturdy wall. Concrete is a composite material that created from cement. Concrete is used due to its low cost and also have a high compressive strength but low in tensile strength. However, aluminium honeycomb structure on the other hand not only has a high compressive strength but also has a high tensile strength. It also reduces the amount of material used. So in this project, a combination between honeycomb panel with natural sugarcane fiber is used to find is it better in mechanical properties than the normal sandwich aluminium honeycomb. The objective of this research is to fabricate sandwich sugarcane fiber and polyester resin with aluminium honeycomb panel. Next is to identify the structure and flexibility of combination of sugarcane and polyester resin with aluminium honeycomb. The first literature review is about testing and modeling tearing and air effect of aluminium honeycomb under out-of-plane impact loading. In this research, it used different types of tests for block and bumper honeycomb to know its behavior when under quasi-static and dynamic loads. There are three types of tests. The first one is uniform compression. Second one, compression shear in LT and WT section. And the third one is indentation. Next literature review is about quasi-static cutting response of combined hexagonal aluminium honeycombs at various stacking angles. In this research, it used a composition of multi-layer aluminium honeycomb panel that also known as CHAH, and it used because the densification strain of combined structure for the CHAH is higher than the single layer honeycomb panel. However, the mechanical properties and energy absorption mechanism is not clear. For the third literature review is about synthetic fiber reinforced concrete. Synthetic fiber have gained appeal as reinforcement for cementitious material in recent years. They can provide an effective and reasonably inexpensive alternative to asbestos, steel and fiberglass for concrete reinforcement. If the fibers were fully optimized, the same or greater improvement in the characteristic of fiber reinforced concrete may be achieved at a lower cost or without increasing the cost of reinforcing. Next literature review is about a review of recent developments in natural fiber composites and their mechanical performance. Natural fiber composite or NFC are gaining popularity for a variety of reasons, including their potential to cost-effective replace synthetic fiber reinforced plastics while also enhancing sustainability. For its advantage, it has low density and high specific strength and stiffness. Fiber are a renewable resource for which production requires little energy, involves CO2 absorption while retaining oxygen of the environment. Next, fiber can be produced at lower cost than synthetic fiber. Furthermore, it has low hazard manufacturing process and has low emission of toxic fumes when subject to heat. And lastly, the advantages of natural fiber composite are less abrasive damage to processing equipment compared with that for synthetic fiber composite. The advantage for using natural fiber composites are it is high moisture absorption, which can be result in swelling. Next, it has lower durability than for synthetic fiber composites, but can be improved considerably with treatment. Next, it also have lower strength in particular impact compared to synthetic fiber composite. Next, it has greater variability of properties and also have lower processing temperature limiting matrix open. Following are the primary parameters that influence NFC mechanical performance. The first one is fiber selection. In fiber selection, it must include the type, harvesting time, extraction method, aspect ratio, treatment, and fiber content. The next parameters is matrix selection, interfacial strength, fiber dispersion, fiber orientation, and also porosity. For the last literature review is about compression characteristic of honeycomb sandwich panels to improve their impact resistance. Honeycomb sandwich panels are composite panels constructed by gluing thin surface plates such as CFRP, laminates or metal sheets to aluminium or aramid honeycomb cores. Sandwich panels constructed of honeycomb are lightweight and extremely strong. As a result, they are widely used in a range of sectors including transportation equipment, and particularly well suited for lightweight, high-performance aerospace application. In this thesis, it offers a combination of aluminium honeycomb with sugarcane residue. Next, size of one honeycomb is only 1.5 cm to 2.5 cm. The material that we use in this thesis is, the first one is aluminium honeycomb panel, next North sodium polyester resin, and lastly natural sugarcane fiber. The equipment that used to complete this experiment is electronic balancing, a stirrer, an oven, a mold, and also Shimadzu TCE N300 universal machine. This machine is used to carry out three-point bending testing. Next, for the experimental setup, three-point bending test is the modulus of elasticity in bending, and the material's flexural stress strain response may all be determined using the three-point bending flexural test. This test is carried out with a three-point bend fixture on a universal testing machine. The major benefit of a three-point flexural test is how simple it is to prepare and evaluate the specimen. The result of flexural testing show the average maximum stress and also show the average maximum strain. As we can see, for the highest fiber specimens have the highest average maximum stress, which is in 3.166 megapascal. Next is about the effect of flexural test. As you can see, the 0-gram fiber completely shattered the first layer of resin and completely bent the specimen, and it is proved that the max strain is the highest. The first sample for 4-gram fiber breaks at the bottom part of the resin. The second sample for 4-gram fiber breaks at both top and bottom side of the resin. Meanwhile, for the third sample, the bottom part is break. The first sample for the 12-gram fiber breaks at the top part of the resin. For the second and third sample, It is also breaks at the top part of the resin. And lastly, for the effect of flexural testing for the 20 gram fiber sample 1, breaks at the top of the resin. Meanwhile, for the second and third samples, breaks at the both top and bottom part of the resin. In this experiment, a graph of stress versus strain was produced. It is generally agreed that stress-strain curves are curves that represent the relationship between stress and strain in any kind of deformation. The graph of stress and strain for each specimen are shown in illustration below. There are 3 graphs for each specimen since each specimen has 3 samples, from which to calculate an average. Whenever a material is exposed to a load, its reaction is represented graphically by a stress-strain curve. So the first graph is for 0 gram fiber sample. Next graph is for 4 gram fiber samples. There is 3 samples. Next graph is for 12 gram fiber samples. And lastly, graph for 20 gram fiber samples. As a conclusion, the fabrication of a sandwich of sugarcane fiber and polyester resin with aluminium honeycomb was successful, with the sandwich proving to be excellent and sturdy enough to be used as a replacement structure. Furthermore, the maximum stress and maximum strain shows that the fiber augmentation will affect the mechanical properties. In this research, we can conclude that the more the fiber added, the more the stress that the specimen can handle. Finally, some recommendation for future work can be made. The guideline for mechanical testing of sandwich sugarcane fiber and polyester with aluminium honeycomb panel must be improved. The recommendation as follows. So the first recommendation is for type of resin. In spite of the use of polyester resin, there are many types of resin that can be used, such as epoxy resin and also vinyl ester resin that can be studied to achieve improved mechanical and physical properties. Next is for the sample fabrication. At the moment, it is not accurate to boot the specimen as the surface is uneven. It is because the fiber size is too big. It is between 1 cm to 5 cm. If the fiber is smaller, maybe the surface of the specimen would be even. Additionally, the aluminium honeycomb may be stacked together to absorb greater energy. And furthermore, the size of honeycomb panel may be varied. The size of height of honeycomb can affect the mechanical properties of the honeycomb. And lastly, for the analysis test, this research is focused on flexural test. However, other testing can be used to test the specimen,